that part. All right, so what we're looking at today is we're going to take a figure and change it. Maybe we're going to make it twice as tall, maybe we're going to make it twice as wide, maybe we're going to make it both twice as tall and twice as wide. We're going to see what happens to the area when you do that, what happens to the perimeter when you do that. Because then you can predict what's going to happen. Like if I want it to be twice as tall and twice as wide, how much more paint do I need? Do I need twice as much paint or not? That's the kind of thing we're looking at today. So let's start by having you find the perimeter and area of this little rectangle. Find this perimeter, find this area. Perimeter, add up all the sides. All the sides. And we're going to calculate. Label what kind of units for each one. What's the perimeter? Abram? 22 feet. And the area was what? Brendan?
28 feet squared.
Correct. Okay, now we're going to do something to that rectangle and then recalculate and see what happened to the area. I think is what I started with. I want you to triple the height. So change that rectangle so it's 3 times as tall. And then refigure the area. Now if you drew yourself a picture, are those two triangles similar? Is it the same, just a larger version? Well, it's kind of distorted, isn't it? It got a lot taller. It didn't change the width at all. You're kind of tempted to make it wider when you draw it, but it should have just been taller, like 3 times as tall. So when you calculated the area, what was it? 84, and originally it was 28. So it went from 28 to 84. How many times bigger did it get? Was it 3 times bigger? So we made the height 3 times as much, so that made it cover 3 times the area. The original one and the recalculated one. So does that make sense? It's kind of like stacking 3 of those same rectangles. The space that one of them covered now is covered by 3. All right, let's take the base and height. So now triple not just the height of the original one, but triple the width, the base of it also. I want you to figure the area, but also the perimeter on this one. What's the new perimeter and what's the new area? I think I listed perimeter first. What's the new perimeter? How much? Oh, I got 66, because you're adding 12 and 12,
Yeah,
and then 21 and 21.
yeah, I didn't do that.
Right, and the new area, 12 times 21 was 252. Okay, now let's think about what happened on this one. Got the original perimeter was 22, you multiplied how tall it was by 3 and how wide it is by 3. And the perimeter ended up being 3 times as much. So every side got 3 times as big. So when you add up 3 times everything, it ended up 3 times what the total was to start with. So what's the effect on tripling both ways? The perimeter is also tripled. Okay, how about area? That didn't triple, did it? Did it multiply by? 9? Got 9 times bigger? Now, why would that get 9 times bigger? Well, as you look at the picture, do you see 9 smaller rectangles making up the big rectangle that we now have? So visually, that might be a reason why it is 9 times as big. So you made like a row of 3 rectangles, so I know it covered at least 3 times as much. The next row has 3 more, and then 3 more. So when you consider area, you are affecting the length and the width. You're affecting 2 dimensions when you figure area. So if you are multiplying this one by 3 and that one by 3, when you multiply together, the area 3 times 3 is going to be 9. So that's where it gets its 9 times as big. Okay, let's see if it works on or what happens on a triangle. Okay, first of all, find the perimeter and area of this triangle. You have to find the missing side. Missing side is, the hypotenuse was 5, the 3, 4, 5 triangle that we've worked with a lot. So perimeter, when you add those up, you get 12. And the area, 1/2, 4 times 3 is half of that because of the triangle, 6. Okay, so now let's take that triangle and change something about it and see how that affects the area or the perimeter. Okay, I want you to double only the base of the triangle. And then figure out how the area changed. So double just the base. And I don't care what the new area is, what I want you to tell me is what effect did that have on the area? How did the area change? Double the base. Area figured. So how does that area compare to the original area? Was this big? Yeah, it was like perimeter on that last example. So what happened to the area? 3 times as big? 2 times as big? Did you double it? Yeah. So instead of taking 1/2 4 times 3, you were taking 1/2 8 times 3? Okay, so that should have been that it was doubled. Those triangles are not similar, right? We stretched it one way but not the other, so that they are still both triangles, but they're not similar triangles. They don't have the same angles. The side ratios would not all be the same. So we doubled only the base, and the area was just doubled. What happens if we double both the base and the height? We double both the base and the height. Let's see what happens to the perimeter and the area. to the perimeter. Since we're talking about doubling, did it double the perimeter? Yes, no? What was the perimeter when you doubled it? I got 24 for the new perimeter. So originally, we had a perimeter of 12, now it's a perimeter of 24. It sounds like that did double.
Why'd you double?
What?
Why'd you double the hypotenuse?
Well, can you keep the hypotenuse small? No, you can't keep the hypotenuse at 5 if the two side lengths. So by doubling the sides, you're automatically doubling the perimeter. All right, an area was a 6, now it's 24. That didn't double. What happened? How many times bigger? 4 times bigger. So we would say that the perimeter doubled and the area was multiplied by 4. So it's covering 4 times the space, but the edges of it only got twice as big. Why covering 4 times the space? Again, area uses 2 dimensions. And if I would draw in here, I probably could get you to imagine, that was the original triangle, like 3 by 4. Same here, 3 by 4, 3 by 4, 3 by 4. This one's just flipped over upside down. So the whole region could be covered by 4 of those smaller triangles. So the area got 4 times as big. I know you're probably thinking, well, in the last one, it didn't get that many times as big. The difference in what we're doing here, sometimes aren't we changing one dimension, and then maybe the next screen we're changing both dimensions? It affects the area differently depending how many dimensions you're changing. The perimeter, I didn't ask you the perimeter all the time. If I go back to the last screen, if we doubled only the base, notice I didn't ask you anything about the perimeter, because the perimeter doesn't change in a nice way. We're not changing the 3, but we are changing the 4, which also affects the hypotenuse. So we're not getting everything doubled. So the total perimeter doesn't double until we double both dimensions. If we figure area and just stretch it one way, the area is going to do whatever you did. Stretching it twice as much, the area is going to be twice as much. But if you make it twice as much both directions, area uses both dimensions, so times 2 and times 2, you would get it 4 times as big. So in what we're looking at today, you need to consider, is it changing in 1 dimension or 2 dimensions? Okay, here's a summary that I'm not sure if, did I type that on there or do you need to write this down? If you change only 1 dimension of a figure, the area will change in the same way. If you change only 1 dimension of a figure, like only the width or only the height, you won't be asked about perimeter because not everything changes, but you could be asked about the area. The area will do whatever you did to that 1 dimension. So taking it times 5, the area would be times 5. Multiplying the height times 2, the area will be twice as much. The second thing, if you change in both dimensions, like you're changing the length and the width, or the base and the height, the perimeter is going to change in the same way. You double the width and you double the height, that's also going to double any other side involved. It's like you're enlarging the whole thing twice as much, so the total perimeter is going to be twice as big. So whatever you did is going to affect the perimeter in the same way, and the area is going to be whatever you did squared. Whatever the change is squared. If you take each dimension times 3, the area will be 3 times 3, 9 times as big. If you're doubling the length and the width, double and double, you're gonna take the area times 4. So part of what we need to think when we're describing what's gonna happen is this changing it in one dimension or 2 dimensions? Is it changing it both ways or just one way? Because your answer is different depending upon how many directions it's changing. Got those sentences written down? Okay, so we're gonna see if we can not completely recalculate. Can we get to the point where I can describe what change is gonna happen and you can tell me what'll happen to the area or perimeter? That's where we want to get to. We can double check by calculating, but we probably don't have to calculate all the time. All right, ready to go? All right. Some of the changes will say you're multiplying by something, maybe multiplying by 5, maybe multiplying by 1/3. Maybe they'll say you're dividing by something. So kind of word what's going to happen in the same way that they worded the problem. They're saying multiply, you say multiply. They're saying divide, you say divide. All right, so what's going to happen to these rectangles? The base and height of a rectangle that had a base of 4 and a height of 5 are both multiplied by 6. So look at what happens when you change both dimensions. In your notes you just wrote down. What effect is the perimeter going to have? Perimeter will be multiplied by 6. Area will be multiplied by change squared. So multiplied by 6 squared, which is 36. So the area will be 36 times as big. It will be multiplied by 36. All right, how about if we are taking that rectangle with a base of 4 and a height of 5, and the base is going to be divided by 3. We're only changing one dimension, so read the correct sentence. What happens to the area? Area will be divided by 3. Didn't ask about the perimeter because some of the measurements changed, but the others didn't, so you can't really predict what's going to happen.
Do we have any problems where like the bases sometimes
It's possible, I don't think I assigned any of those, but if the base is times 2 and the height is times 4, they're not going to ask what the perimeter did, but they could ask what the area did. If you're multiplying by 2 this way and by 4 this way, the area is going to get multiplied by 2 times 4, 8. So it is possible, I don't think that I assigned any with that type. Okay, circle. The radius of the circle is multiplied by 1/5. What's going to happen to the circumference and the area? I think when you change the radius of the circle, is that changing just the width of it? Or does it affect the width and the height of the circle? To keep it the same shape, the circle, the radius, doesn't that make it taller and wider at the same time? So this is like changing both dimensions. Okay, so read the sentence about changing both dimensions. Perimeter is same as circumference in a circle. So what's going to happen to the circumference? Multiplied by 1/5. Area multiplied by, square that, so 1/25. Right. And just to prove, there's the calculations. It got 1/5 as much on the circumference and 1/25 as much on that area. A square. The sides of the square are multiplied by 8. Determine the effect of the change on perimeter and area of the square. Okay, so think, does that affect it in 2 dimensions or 1 dimension? It's a square. Changing the sides. It's going to be affecting both dimensions. So if I make it 8 times as big, it's going to get huge. So what happens to the perimeter? Multiplied by 8. Area multiplied by 64. And there's the proof if you need to look at the actual numbers. Perimeter got 8 times as big, area got 64 times as big. Give me a thumbs up or down if you're with me. I'm not getting a lot of response from everybody. Okay, seems like you're understanding. Okay, so this is the thought, the radius or the side of the square, or if it's any regular polygon, when you change like one side or one radius, you're going to change both dimensions. So grab your marker board here. want you to be clear on your marker board, like perimeter will be multiplied by what, area will be multiplied by what. Okay, so this one we have regular hexagons. The base and height of the regular hexagon are both multiplied by 1/3. So what effect will that have on its perimeter and on its area? How will that affect the perimeter and the area? Wasn't that the second day in a row we had something wrong? I'm gonna have to start collecting them again. Okay, perimeter will be multiplied by 1/3. Area is gonna be multiplied by 1/3 squared, which is 1/9. Because that changed both dimensions. Okay, here's how they worded the theorem. I don't know if you like that wording. I didn't really like the wording on their theorem, that's why I wrote those sentences for you. But it's talking about it changing by a factor of a or a factor of a squared, but it's only if all dimensions. I put the one dimension idea in there too. Okay, if the diameter of the circle is multiplied by 4, what happens to the area? Will that change one dimension or two? I just asked about area on this one. You don't have to do it all the time. Area will be multiplied by 16. Does that mean the area is 16? No, it's 16 times bigger. Okay, and if the radius is multiplied by 9, what happens to the circumference? What number is that? Okay, multiplied by 9. Okay, now what would be, I think I'm going to skip those there. The other part is, back in chapter 7, you might remember this theorem. We were working with similar figures. If the similarity ratio is A to B, then the ratio of perimeters is also A to B. And the ratio of the areas is A squared to B squared. That's really what we're doing right now, just worded in a little bit different way. We also looked at the one dimension thing. This chapter was making similar figures, so it was always twice as big all the way around. You didn't just change one dimension. But what we can do then is go back to what we had in that chapter. So if our similarity ratio is 4 to 9, what's the ratio that compares their areas? Similarity ratio, let's go back to that theorem again. Similarity ratio and perimeter ratio are the same. I don't know if I put that in your notes again, if you need to write it down again. The perimeter ratio and the similarity ratio are always the same. The ratio of the areas is squared of whatever that is. So the answer to the question, yes, if you compare perimeters, it's going to be the same as 4 to 9. If you compare their areas and reduce, it's not going to be 4 to 9, it would be 16 to 81. When closest to him. So the idea of the square ratio. Now here's what I want you to be able to do in this lesson. We're going to try and find the missing perimeter and area. Okay, so we've got two similar triangles. I told you the perimeter and area of the big one, but we can use these ratio ideas to find the perimeter and area of the small one without even finding every side, because I don't know enough side lengths. Okay, we can do it all with ratios. Let's figure perimeters. Okay, the perimeter of the first one is 36. Perimeter of the second one, we don't know. Probably put this in your notes so you can look at it, not just on the marker board. Perimeter of the second one, I don't know. But what ratio should the perimeters be in? Did we change both dimensions to make them similar? Yeah, you have to change everything to make it similar, otherwise it's distorted. So this is a changing both dimensions idea again. The ratio of perimeters is the same as the ratio of the sides, the similarity ratio. I have two matching side lengths up there. I can use that to establish what ratio the perimeters should be in. So if I compare the perimeters, that's going to be in the same ratio as comparing the sides. Those two ratios are always the same. Do a quick cross multiplying for me. What's the missing perimeter? Missing perimeter. .2. Okay, so think what I did. I just made a ratio out of the perimeters, but I knew that had to be the same as the ratio of the sides. Now when we do area, it's not quite the same thing. Area of the first one I know 60, area of the second one I don't know. What ratio should that be in? Is it the same as the ratio of the sides? No, it needs to be the ratio of the sides squared. So set it equal to 13 squared over 9.1 squared. You need to square the ratio if it's the area you're working on. You cross multiply, get your squaring done in there. Should be a smaller area than what we had. If you want to square each of those numbers and then do your cross multiplying, I don't care. 60 over A, 169 over 82.81. Multiplied by 60, and divide by 169. I get 29.4 for the missing area. Not right? So what's a key to these problems that I'll have you go back and do a few from chapter 7? Setting up the perimeter and the area ratios equal to the correct thing. Where did I get the 13 and the 9.1? Those were the matching sides. Ratio of perimeters is the same as the ratio of the sides. But when I did area, I had to square each of those because as we're changing both dimensions, it's the square of that relationship. So let's try one more of these before we end. Got down what you need from there? One more? Let's see, that's the same one. Okay, let's try this one. These two triangles are similar, which means we changed both dimensions at the same time. So find the perimeter and area of the smaller one, triangle ABC. You're gonna set something up to cross multiply. I'll write down what I think you probably set up or should set up. That look like what you set up? Why did I square the area ratio? Because if you change both dimensions, it has the effect of squaring the relationship. If you wanted to reduce that to 1/2, 6.5 to 13 reduces to 1/2, you could do that. So the perimeter should have been half as much, 27 inches. And the area should have been 1/4 of what the original one was, 31.5. Raise your hand if you got that right. What do we do on that? Okay, quite a few correct. Questions? Okay, so here are the problems we work on. This down, it seemed like I had a second page and I don't have it listed there. While you're getting started on the quiz, I'm going to look that over and see if that had some of these in it or if I forgot to